132 people have died from the virus.
Is Italy, where infections have jumped by 50% in 24 hours.
Coronavirus.
Taken to screen passengers.
Corona-Epidemie.
Virus, Pandemie.
Katastrophen.
You should ask China.
Just finish this last bit. Even though there's literally no point of an exam during a pandemic. Okay, let's see.
Hi there, I'm Asta. Physics is everywhere. Even right now, we can use physics to study the structure of the virus.
Exactly how do we do that?
Well, to make vaccines, we have to actually first understand the structure of the virus, which can be done at synchrotrons.
Synchrotrons? Where electrons are accelerated in a ring and collide?
Yep, and to produce high-intensity X-rays.
Wait, you want to zap the infected people or the virus away?
No zapping here. So the structure of the large biological molecules like COVID-19, proteins and DNA are revealed using the X-ray crystallography techniques that are used at synchrotron. COVID-19 was first revealed at the Shanghai Synchrotron Radiation Facility in China.
Oh, X-ray crystallography. That's arguably one of the greatest inventions of the 20th century. 28 Nobel Prizes have been awarded to projects related to crystallography. Involves a beam of light being fired at a crystal. The crystals contain electrons, but these electrons have some spacing in between. The wavelength of the X-ray is similar to the spacing between the electrons in the crystal. This allows diffraction pattern to be produced by the crystal, which appears as a pattern of random dots that are scattered by the beam hitting the electrons.
Exactly, and we can do this with the crystals of the virus protein. Then the diffraction data that we've collected, we can use that to calculate the electron density. The electron density is the number of electrons per unit volume. Now, the positions of these electrons can be located. This is called localization. Once all the positions are put together, we can visualize the shape and structure of this molecule.
And the preciseness depends on the resolution of the diffraction data. The resolution of a diffraction pattern depends on how ordered the crystal is. If it's highly ordered, the crystal will diffract to high resolution. The more disorder there is, the lower the resolution of the diffraction image. The intensity of diffraction spots drops with increasing disorder.
There is actually another way, because some molecules refuse to be crystallized.
So then what do we do?
The answer to that is more physics. Even if the molecules refuse to be crystallized, there's still a chance of obtaining the structures. Well, we can use something called cryogenic electron microscopy.
Cryogenics is the behavior of materials when they are put to very low temperature using liquid nitrogen.
So we cool the virus particles using that technique.
But you said cryogenic electron microscopy. Electron microscope consists of an electric gun that accelerates electrons at a high speed through a vacuum inside of the microscope. So like before, we study the data, this time the data being the transmission and scattering of the electrons, and then we build the structure.
Once we have the structure of the virus, we're a step closer to making the vaccine. There are proteins on every virus. These help the virus weasel its way into the host cell. For COVID-19, you can see them as spikes on the surface, so understanding these spikes could help develop antibodies and therefore antiviral drugs and vaccines.
So next time you think physics is only used at CERN or the typical ways like mathematical models, remember, physics is actually everywhere.
One. Bored physicists.